Welcome again to Educator.com, Intermediate C++. Today we'll be talking more containers, specifically set and map. Sets and maps have slightly different data structure from a linked list. They have a binary tree, which gives them fast access. Now, there's a certain cost in that for your insertions and deletions, but it's worth it for the fast access for sorted objects. And we will introduce a pair object real quickly, and we will introduce the containers set and multi-set. The difference being the set is unique keys, multi-set can have multiple keys, duplicate keys. Right, it says right there. And they're sorted automatically. It's kept in a binary tree. It's kept in order. And as soon as you add a new node, it will go look where does this go and put it in order. Multi-set allows duplicate values. And we'll talk about how to get data in and out of a set or a multi-set. And we'll also introduce map and multi-map. Same type of thing where the map is unique keys and multi-map is duplicate keys. The difference between a map and a set is a map maps one value to another value. And we'll talk about how to get data in and out of maps and multi-maps, and how to provide a custom class for doing the comparisons. Just how do we know that these two guys, well, this guy belongs in front of this guy? If it's integers or doubles, it's not a problem. If you have custom class, you may need to provide a function that says this class object needs to go before this other class object. So you give it a class for that. And what happens if you try to put in something into a set or a map and it's a duplicate, it's not allowed to go in? How to make that determination? So here we have a tree structure. These are basically the same integers in the same type of thing that we had in the linked list last time. Only now we have a tree structure. So we go into here and we're looking for a specific number. Let's say we're looking for 150. 150 is less than 267, so we go that way. It's more than 139, so we go that way. It's less than 205, so we go that way. Ah, there it is, 150. Now, if we were looking for 149, we'd go through here and say, well, there's no more after that, so 149 is not in here. And you may need to add it if you're going to add it. Well, let's see, we have 271. Blah, 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 blah. 271 is less than 275. So we would erase that, and now that points to there. And then this guy is null terminated. Now, well, what's the value of this? Your value is in searching. Let's say we're looking for, let's do something nice and low. It's 342, way down here. If you have this in an array, if you have this in a linked list, you're searching through it. So is it 15? No. Is it 27? No. Is it that one? No. That one? No. No. Blah, 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 blah. You search, and then you finally find, there it is. Whew. All those searches before you get to it, that's very time consuming. Binary tree. We start here, is it 267? No. It's greater than 267. We go down here, it's less than this, it's greater than that, so there it is. So it's 1, 2, 3, 4 searches, bang, there you are, very fast. There are other types of trees that are n array, you could have 3 of them instead of 2. You have any number of them. You say, well, we'll divide our, it depends on what your data is. This is arbitrarily evenly distributed because I took the data and I built a tree around it. When you get the data and you start constructing your tree, it may not automatically come out this way. If it's poorly distributed, you could have, like, for example, lots of nodes all going in this direction. So if you're searching for something that's above that, it's very fast. If you're searching something in this area, it can be very slow because it's not distributed well. And there's all sorts of algorithms and systems to keep your trees balanced. But we're not going to worry about any of those because all this will be taken care of for us by the system. Okay, we're going to talk real quickly about a pair. You include the utility linked list, and basically it's just a template structure where you've got first of whatever type you give it, and second of whatever type you give it. It is used in sets, it's used in maps. We'll talk about those when we get to them. But what this does, it allows a function to return 2 values instead of 1. Basically, it's returning one object, and that one object has got 2 data members in it. So you define the first value as an iterator to a container's element, and you define the second value as a Boolean, and it indicates a success or failure of an insert. If you try to insert something that's a duplicate, the Boolean will be set to false. So here's an example here. We have a pair, and we have our type brackets. The first type is going to be, this is an integer set. This is our iterator, our namespace operator. So we're taking the iterator of our integer set, and that's going to be the type of the first element of the pair. And then bool is the type of the second element. And so we're defining this variable. This is now a pair. Now, if we set it equal to, we have my set, which happens to be an integer set, and we insert 170. Now, if 170 is not in there already, bool will be true, we'll have a successful insert. If it's already there, bool will be false. In either event, the iterator will point to an element that was either inserted or attempted to be inserted. And we also use a pair for keys and maps in the key and value in a map object. So in that case, the first element will be the type of your key, the second element will be the type of your value, and you will put that pair, insert that into your map. So here's an example for a map with a string key and a double value. So we define the pair. String is the type of the first. Double is the type of the second. And here's the value, the variable, which is the pair. And we're initializing the first one to my key in quotes, and the double value is 998.8. So if we print out the first value, it'll print my key. If we print out the second value, it prints out 998.8. And so now if we had a map where this was the type, we could take this value and insert it into our map so that later on we could search for my key and find out that my key is associated with 998.8. Now, getting into sets and multi-sets now. If it's a set, you need to include the set type. If it's multi-set, you include that, and you're likely to use pairs. If you're not going to do any insertions, or you know you're never going to have to test it, you don't have to include the pair. But you probably should just include utility. It doesn't hurt to include it. And that gives you your pair object template. So what a set is an associative container. It's not sequential in the sense that a vector or a list is. A vector, you have your first one, your second one, your third one, your fourth one, your fifth one. It's not necessarily in order. It can be in order, but the primary order for the vector is 0, 1, 2, 3, 4. The same thing with a list. You've got the first list node and the pointer to the next list node, pointer to the next list node. For a set, you put it in there and it's in order. You don't care where it places it. It's somewhere in the binary tree. The order is whatever the ordering is. If it's alphabetical, it'll be in alphabetical order. If it's in order of the integer, it'll be in order of the int. If you define some function to define what order they're in, it'll be in that order. Now, a set, the elements are the keys. That's the thing that has to be unique for a set. They're automatically sorted, typically using a binary tree structure, not necessarily. They can use whatever structure they think is most efficient. They can redefine it, they can rewrite it, but you don't even care what order, as long as your functionality works the way you expect it to. And you can give it a class to tell it what custom order you want it to be. The set, like I mentioned, requires the keys remain unique. A multi-set will allow multiple keys that are all the same. And with a set, if you attempt to add a new element and it's already in there, you'll just ignore it, which is why you need your pair to find out, did this insert go in successfully? So let's get some data into this set. So here's our constructors. You have set. You have the type of the set and the variable. This is our empty set. You can give it a class as a second parameter in your type. So this is your type will be a class. Is your comparison class, and we'll talk later about how to define one of those. And it's a custom class that you write for it. So if you have a class that you've written, that'll be the type. You have another custom class that you write that says, okay, this class object is less than this other class object, so this one should be sorted before that one. And of course, you can use iterators to load data in from some other container. And you can also have a custom class and load values from another container. You can insert a value, which would be of the type of your set. It would be T, the value type of your type would be T. If it's an integer set, then this will be an integer. If it's a double set, then this will be a double, etc., etc. So we insert a new element with this value, and it returns an iterator bool pair. So it's a pair where the first type is a set of your type iterator. So you would write that up here, it would be set T, and then its iterator. That's the first part of the pair. The second part is bool. So you can define a pair with those two types. That would be the return value for the insert. So you could test this bool to see if that insert was successful. An iterator will point to the element that was inserted or attempted to be inserted. You can also insert at a position, and it won't go into that position. But what you're doing is you're telling the set, I think it'll be close to here. So if you know roughly where it's going to go by however you're processing it, then you can give it that. It'll be a little bit quicker finding its real position. It's sort of like a little shortcut, like a hint. This should be close to the end. So put it in there close to the end. If it goes close to the end, it'll be very fast. If you give it a bad hint, well, you might actually be slower than leaving it out. But so this will begin searching at that position to put it in there. Like the intelligent use of that can save your time. We're not going to talk about unintelligent use. And of course, we have insert, where we take a range of iterators from some other container and insert them into your set. Now let's get some data out of the set. We'll go to a particular position, erase it. It will be destroyed. If it's a class object with a destructor, the destructor will be called. Go from the first to the last. Those, again, are iterators that are pointing into your set of specific objects. Give it a value. It will find that value in the set and destroy it. Or you could find a given value to get an iterator. So you can call find a couple of times to get the first one and the last one and erase them and perform it from the first to the last. If it doesn't find it, it will return the end. So remember how this works. Your for loop goes until you go past the end. So let's give a quick example. We have 10, 20, 30, 40, 50, and they're all in the set. They're all in order. Let's find 20. Your iterator's there. Let's find 40. Your iterator is there. Erase from first to last. It will erase that, and it will erase that, and it won't erase that one. If it can't find it, it will be the end. So you go from, if you say go from there to the end, this is the end, let's say end here, which is off the end of your set, then it will erase all of those. So now your set is very small, it's only got 10 in it. We have lower bound, which returns an iterator to the element that's equal to that value or the next greater. If it's not there, it goes to the next one. So say we had 10, 20, 30, 40. Find lower bound 25, it returns 30. Upper bound, this will be the next element again. Let's say we look for 35, it will give you 40. Again, the iterators are positioned so that it works like your for loop, where you have your beginning is the actual first one, and the ending is the one after the last one. So this loops until it is not equal to end. When it's equal to end, it will not enter the loop. It will stop. So always remember, end is one element past the end. And here's some examples of a set. Here we have a nice set called mySet, which is a very creative name. It's an integer set. So let's load it up. We've got for I equals 0 until it's less than 20. That's going to be 0 until 19. I plus plus. Let's insert I times 10. So inside the set we'll have 0, 10, 20, until we get to 190. Now we define a pair. That's an iterator and a bool, and we've declared it to be P. So P is our pair now. So now we have P equals mySet, insert 70. Well, 70 should be there already. So we should be able to say, if not mySet second, so if it's not there, we'll erase it. But this really doesn't make sense. We should erase it if it is there. Oh, no, here we are. If it's not there, it's there already, but we don't want it there. So if it is there, then we'll erase it. So now 70 is not there. But it still doesn't make sense, because if it was successful, it is there. But never mind, this is just to demonstrate how all this stuff works. So here we have an iterator called iterary low. Iterator, we said it's a lower bound of 35, so that'll move on to 40. And then iterator high is the upper bound of 100. And just an iterator for looping through the set. So we're going from low until we go past high, and just print out the value in that iterator. So we should get 40, 50, 60. 70's been erased. 80, 90, and 100. And we'll do another one. We'll get mid. We're going to find 120. It's mid 2. We're going to find 170. And we're going to erase from mid 2 to the end. And then we're going to iterate through the loop from mid 1 until the new end and print it out. So 120 is here, 130, 140, 150, 160, 170 on end has been erased. So these are some operations working on an integer set. Now let's move on to the map. Again, if you're going, we'll be using pairs, so you should include the utility in order to get the definition for pair. And again, it's another associative container. It's not a sequential container. But the element, instead of just storing the elements, you're storing the elements as a key, and that key is associated with a value. My favorite example is like you say, well, CA is a key into your state table, and it's associated with California. So that would be a string-string map. So the elements, again, are automatically sorted according to the key. The value doesn't have to be in any particular order. The value is totally arbitrary. You can give a custom class to decide how you want these keys to be ordered. And the map requires unique keys. If you insert a duplicate key just like a set, it'll say, I've got this already, I'm going to ignore it, throw it all away. The multi-map allows multiple keys. Now the thing about a multi-map, if you say, give me this key, it's, oh, here's the first one I found. So the only way to get all the other ones is to use an iterator to actually iterate through them. Now here's some constructors. Again, now we've got two types that go inside for the map descriptor. There's the type of the key and the type of the value. And of course the variable being defined. Here's the empty map. Here we have three in there. We have the key, we have the type, and we have the class that we'll use for comparison. We have a custom comparison class. Here's where we're going to use iterators to copy from another container into our map. And here's the same thing again with a custom class. So here's where we're going to insert a pair. So we have the pair with the key and the type that should match the key and type of your map, and the key and the value that's being inserted into your map, which will return the iterator bool pair, just like in the set, where the iterator is pointing to what you tried to insert, and the boolean telling you whether or not it was successful. So the iterator points to the attempted element, and the bool indicates if the key was successfully inserted. Here again, we have a shortcut position that says, I think it should go roughly around here. And okay, we'll try and find it close to there. And of course, we have our iterators. We're going to copy from another container from the first iterator to the last iterator into this particular map. For example, if you had a vector of your type, let's call that V1, and you've loaded up with a bunch of objects. Or let's not make it a vector because we don't know what the keys are for the vector. Let's say we have another map out there. So we want to copy the entire thing into a new map. So we'll have our constructor with the same key and the same type, which is take V1 begin to V1 end. So we'll copy everything in the V1 map into the V2 map. Now let's get the data out of the map, in and out actually. The map gives you the array operator, the open and close square brackets. It uses the key like it was an index into an array or a vector, but instead of an integer, which is what the arrays and vectors use, it's whatever your key type that you're using for the map. So it will insert the element for the key if it's not already there. And it will, if it's not already there, it will call a default constructor. So here's something that will print 1, 2, 3, 0. So we have my map, which is a string map. It's a string key and an integer value map. So we say my map ABCD equals 1, 2, 3. So now in your binary tree, it has constructed ABC and set the value to 1, 2, 3. So let's print it out. My map ABC and my map MT. Well, MT is not in there yet. So, let's put MT in there and set it to the default constructor, which for an integer will be 0. So we print this out, we'll get 1, 2, 3 from the ABC map and 0 from the MT map. And of course we can erase a particular position. We can erase from first to last. We can search for a given key and erase that element. We can find the key, the lower bound key, upper bound key, just like in the set, except we're using the key instead of the element itself. All right, let's get some examples of running some maps. I love the way that this works with a map because you can use this pretty much the way you would use an associative array in other languages such as Perl and things like that. It's very nice. So here we have a map as defined as a string key and a double value. So we're saying Alvin equal to 780.6. We'll pretend that's my credit score. And Freddie is set to 392.5. And we'll change Alvin to 450.3. That's not my credit score. And Bubba, 600. Now, we placed in order. So here we're defining an iterator for the my map string double. Actually, I should just say map. So we have a map string double iterator, IT. So from the iterator equals the begin until it gets to the end. And we'll print out key and value. And since the iterator is like a pointer, this is how you dereference that pointer to get the first object of the pair. The first object is your key. And the second object is the value for that associated with that key. So this in order, this would be Alvin. It should say val. No, actually, it would say key, Alvin, and then val. What I changed it to, which is 450.3. And then it's in order of the key, so next will become Bubba. And its val for Bubba is 600. And then finally, the key for Freddie. And the val is, what's Freddie is 392.5. So that's what our looping through using the iterators will print each key and each value. Now this gets a little tricky right here. We're going to construct a pair for the result of an insert, and we're going to construct a pair for the value that's being inserted. So this is our result P, and this is P Alvin, which is going to be inserted. This is the hard way. This is the easy way. This is the hard way. So we have a pair consisting of a string and double, which matches the string and double of our map as a pair, and we'll initialize that pair to a string value for the key and a double value for the value. So here's the actual insert statement right here. So P will accept the return, we'll have my map insert this value, and it will not change the value because Alvin is already in there. So we'll find out that this insert failed by checking the second half of our return P. If this is true, we'll print out we have a new Alvin. If it's false, we go into else, we say Alvin is already in the map, and then we erase Alvin, which I don't like erasing Alvin, but we'll pretend it's a different Alvin. So we have a comparison class. How do you tell what order the things should be in. Now, if you have integers, you have doubles, you have strings, it's probably pretty straightforward what order you want things to be in. If you have a complex class that you're using as a key, then you may have to write your own order. Or even with something simple, you want all the even numbers before all the odd numbers. You need to write your own class that does that comparison. So the map will call the class, or the set will call the class, whichever one you're using, and it will call that class. Does this object go before this object? If it's true, then it will order them that way. If it's false, then it will order them the other way, or it will not change the order, however it works out. So set, multi-set, map, and multi-map can be provided with a class that you have to provide this class when the map is constructed, when the set is constructed. So here's an example. We have an integer set with evens before odds. So we're defining this class. A struct is like a class in C++. The difference between a struct and a class is the struct defaults to public, class defaults to private. We're using struct. This will be public. We're calling the structure even before odd, and we're overloading the function operator, the open parentheses and close parentheses. And we have two parameters passed into this function operator. An integer a, this is an integer, a constant integer reference to a constant integer reference to b, and this method is constant. And this is required so the compiler knows that you're not going to muck about with the values. Otherwise, it will give you an error and won't allow you to use it. So we have constant integer reference a, constant integer reference b, which is a constant. And what the code is, if a is an even number, of a remainder 2 is 0, that means it's even. If b remainder 2 is equal to 1, that means it's odd. So if a is even and b is odd, we return true because we want a to be before b. If it's the reverse, if a is odd and b is even, then we return false. We want them to go the other way. Now, if they're both even, if they're both odd, then we just want the one that's lesser to go in front. So we just return a is less than b. So there is our class called even before odd, which is a kind of a peculiar type of sorting algorithm. But, it's a sorting algorithm. So here we're defining a set, an integer set, and we're going to use even before odd as our comparison class. And I call it CBO because it's for set even before odd. So we will insert into the set 300, 3, 30, and 101. And it will order that set according to the even before odds. All the even numbers will come first, all the odd numbers will come second. So we'll have 30, 300, 3, 101. Like I say, it's a peculiar ordering, but there's all sorts of other orderings that you might like. If you have a string, you might want it to be a case-insensitive ordering so that Alvin sorts in the same position as Alvin, for example, with a capital A versus a lowercase a. You have to write your own class to do that because C++ doesn't have anything for that native. It's not difficult to write. Now, what happens to duplicates? What kind of duplicates can we get? Well, the insert method for set and map, where we can return a pair template, as we've talked about. You have to include the utility to get the pair definition. You put an iterator for first, which will point to the attempted attempt. If you have an element, the iterator will point to it, whether it gets placed in or not. And Boolean second will be true if it was successfully inserted, or it will be false if it's already in there and was not inserted. So here's an example. We have an integer set called S3. And also we've loaded it up with some arbitrary data. We have X. We have some function in our application. We get a new value for X. So we have a pair with our set, our integer set iterator is the type of first. And bool is the type for second. And I just happen to call the variable p. You can call that p1 or p2. P stands for pair. So p equals S3 insert X. We take this integer value, insert it into set S3. The return value goes into p. So if this is false, we couldn't insert it. And so we can say unable to insert, and we'll dereference p because it's a pointer, and get the first. And here we have some useful maps. You are here. This is where you are. You are not there. And that's it for today's class in today's lesson in C++ in learning about sets and maps. Thank you for being at educator.com. We will see you next time.